Okay, this is the P3 paper from October 2023. It's question number 1. It's a numerical methods question, locating roots and finding fixed point iteration. Let's have a look at the question then. It says y is equal to fx, where fx is x squared minus 5x plus e to the x. We have a function there. Excuse me, the first part says, can we show there's a root in the interval 1 to 2? Well, yeah, absolutely, we can do that. Part A, let's say that fx is equal to x squared minus 5x plus e to the x, and all we do then is work out f1 and work out f2. So f1 is 1 squared minus 5 lots of 1 plus e. That works out to be minus 1.281. And then f2, 2 squared minus 5 lots of 2 plus e, well, that works out to be 1.389. And I hope most of you are aware that the important point is the fact that there has been a sign change there. So get the wording absolutely correct. Since there is a sign change, that doesn't get you the marks yet, since there is a sign change, and fx is continuous. You have to say that second part. Fx is continuous, in the interval at least. Now we can say there is a root. So make sure you've got your own version of that, or copy exactly that phrase down for these location of roots parts, part A of this question. Part B says, iterative formula x to the n plus 1 equals 5xn minus e to the xn. Start with x1 equals 1. And what we've got to do, we've got to find x2 to 4 decimal places, so make sure you do that properly. And then part 2 is one of these, they're getting increasingly more common, where keep repeating the iteration until we get the value to 4 decimal places. So what that means is, well, I'll show you, but you basically keep repeating it until it doesn't change for the first 4 decimal places. Let's do part 1 then. B part 1 says x1 is equal to 1. So x2, excuse me, not xn, x2 is going to be, and I always, for the first one, actually show what I'm doing. So in this case, 5 minus e to the 1 square root of that. That works out to be 1.5105, and they asked to 4 decimal places. So I've given it to 4 decimal places, and then for part 2, we're just going to keep repeating the iteration all the way through. So I'll write the exact value, or not the exact values, I'll write the values on my calculator that I got when I did this, but you don't need to put all of them down. All you need to do is to show that it doesn't change for the first 4 decimal places, I think it was. So I got that, then I got 1.733052248. Continually just taking the new value, putting it back in, 3417541. 1. In fact, x6 worked out to be 1.73396. And again, more numbers there, 132. Let's just have a look then. That was 1.7338, 1.7330, 1.73341, 1.73339. Excuse me, we're beginning to get to the stage, do x7, where the change is taking place further and further down the decimal. This last one that I did was 1.73400. And we can say, look, at least that far then, that's staying at 1.734. That's not going to change there. If there's any more changes taking place, they're taking place over there. So I've gone far enough to now say alpha is equal to 1.7340 to 4 decimal places. And that's what they asked for, to 4 decimal places. It's not going to change there no matter how many more iterations I do. So hopefully that all makes sense.